Okay.
And then I'm gonna make you the presenter, Dennis. Let's do
Okay.
that.
Very well.
All right, you should see the presentation window on your screen. Yeah, I see your screen now.
Okay. Welcome to the presentation here. And my name is Dennis Duke. I'm the professor, the instructor in the class. Right now, I've got a class here that is listening with me, and I know that there are several people who are calling in from the NOVA class, as well as some of the other FIT classes that I've got. All the classes have the same assignment, and what I'm going to do today is try to go through some of the process for the assignment to give you a little bit better idea as to what to expect and how to go about in the assignment. So first of all, if you can see, well, first of all, this presentation is going to be recorded, and Mike Hugos, who is the creator of the simulation, it's his company. He is online from Chicago. He will be giving you a demonstration and answering your questions as they relate to developing the actual simulation. He is also the author of the book, Essentials of Supply Chain Management. He and I have been working together for several years on this simulation. We have presented several papers relating to using the simulation for disaster management, and they are available on the website, as you will see. There's also some other examples of different scenarios that were real life scenarios. So these scenarios you can once you register, you can go in and see the scenarios, and you can play around with the scenarios. As mentioned, this session is going to be recorded. For those of you online, as well as here in the class, you will be able to go into the session, pull up this recording, and review some of the things that I'm going to be talking about today. Because first of all, I'm going to be giving you some suggested process for developing what I call the case study. And this is primarily for those of you on the online class, because there is a lot of different things that are going to be covered here. And I know it seems like an overwhelming project, but everyone feels that way, and I think that you're going to get through it. First of all, as I told you, that each group has to select some type of product. The product can be anything. As I'm going to show you one example here of a class in the spring, that was an FIT class. They chose whiskey as a project. So I'll show you some things of their paper and their presentation. The other one, which was a NOVA class, they chose octopus as a product, and they developed a supply chain for this. So it's a whole lot of things that you can do. It's just up to your imagination. Number one, there's no right answer or wrong answer. The whole simulation, the whole project is based upon how you develop it, how you're able to figure out the situations that you get into, and the logic that you are using to be able to get out of those situations. Do I have a question? Okay. Let me go through the suggested products for developing the case study. Okay, this right here is something that is relatively simple. However, in terms of being simple, it's quite difficult, and it has some steps. So first of all, after you determine what product you are, you're going to have to identify the major markets or demand points. That is, where are the cities that are going to be part of your demand? Are they in the Midwestern states, the West Coast, the Rocky Mountains, whatever? in your selection and in your product, consider the culture, the traditions, religion, people, etc., because this is going to affect your demands. What this particular thing is using is a Cincinnati seasonings, and it's a spicy cube, which is really certain types of spices. Some students use this in previous classes, and some of the things that they brought up was people in different countries, if they populated a certain area, the demand will be higher because they tend to use more spices, etc. So that was one of the points that they brought out. The next thing that you're going to do is, after you identify where your market areas are or where your cities, is what's the annual demand in each market. Because your demand is going to determine what kind of inventory you have, and also going to determine how big your facilities are going to be. So, and I will show you some of the formulas and some of the things that other groups have used for all of this. For those in the graduate classes, this is an undergraduate class that I have here, and they are also doing the assignment. For those in the graduate classes, and Nova, I know that many of you are postgraduates because you already have your master's degree. In your group assignments, or in your past, you have been introduced to various formulas. So you will have to go back into those formulas and use some of those supply chain formulas to be able to justify some of your demand and your forecasting. So again, this is your annual demand. Next is what are the typical sales for a typical 12-month period, because what you're going to do is base your demand on either the past, or you can go into the internet and you could try to find some statistics that really establish what the demand is. So it's totally up to you. And again, I'll show you some samples on how other groups have done it. Then the next thing is you're going to structure the supply chain network to support these markets. In the NOVA class, we have been talking a little bit about strategy, and your textbook in the first couple chapters and some of the assignments that that you had reflect back on the nature of strategy, and the author of the textbook really advocated starting with the customer first and backing up and defining the supply chain. And in many of your inputs, I responded back to say, okay, think about this. How are you going to use this for your final project? So you're going to have to identify some type of strategy. When you look at the strategy, you start establishing the structure of the markets. Now, what you're going to have to do is you're going to actually go into the internet and you're going to pick out real buildings to be able to support your supply chain. I'm suggesting you use cityfeet.com, and that's kind of a real estate site. So you go into the site, you will see what buildings are available. The SCM Globe program uses Google Earth, so you will see the buildings from a map perspective, as well as a satellite perspective. What you have to do is assess the transportation availability to the building. If you're going to have a retail site and you're going to have a big tractor trailer truck, and the tractor trailer truck can't get into the retail site, you've got a problem. So these are some of the things that you really have to look at. When you're trying to look at some of the information, you're looking at all of this information. Can you hold on, Ning? I saw that you had a comment. Let me finish this, and then I'll be able to make you the presenter to be able to ask some questions, okay? As you go along, you're going to estimate, because the city feet is going to give you the square footage. You're going to have to change that to the metric system. It's up to you to determine the operating cost. I'm going to give you several websites that you could get into, utility sites, labor sites, etc. you have to determine both the fixed and the variable cost for the facility. Again, one of the sites is onetonline.org, and you can determine the different labor rates for people who work in a warehouse, who work in a retail operation, regardless of what industry they're in. Then number 6, what you would do is what's the cost of producing your product, in this case a spicy cube. And you have to look at the cost that it's taking you to produce that. That is, what is your raw materials, what is your production cost, what's your labor cost. All of these different things are things that you would consider to be able to put into the paper to be able to document what you're doing. Then on number 7, you would have to research what it would cost to ship 1 unit. Now it's up to you to be able to determine what that unit is. Is it a case or a pallet? Is it a large type of information or whatever? This is dependent upon, again, your product. What I suggest and what other people have done, and I'll show you some examples. You can go to some of the rental places like Ryder, Penske, and Hertz. You can find a lot of information from their trucks. Remember that you have to include insurance, you have to include driver labor, you have to include maintenance, both preventive and corrective type of maintenance. When you're dealing with all of this, sometimes when you rent and you get into a yearly or 6-month contract with some of these big companies, all of that is included except your fuel. And so it's up to you to determine what the fuel is. That may be cost effective. And then once you get all of this information, that's basically your blueprint. And once you do all of this, you then go into the SCM Globe simulation. You start inputting all of the data into the simulation, and then you run it. And as you see here on this document, you're going to determine what the routes are. You're going to determine the delivery amounts, the frequencies, etc. And all of these are going to be dependent upon your formulas in terms of, you know, what's the economic ordering quantity. You're going to have to figure that out. What's the reorder point? You know, how much inventory you should have, how much safety stock should you have, et cetera, et cetera, et cetera. Again, for those in the NOVA class, you should use a lot of this from your undergraduate and graduate classes in supply chain management. The interesting thing that you're going to find is that, and all of the different classes have determined this, is that the formulas tell you an answer, but most of the time the answer is not going to work in the simulation. You're going to encounter problems that things happen. The reason for this is because the simulation is based upon reality, and things happen. Trucks break down, they make wrong deliveries, roads are closed and they can't make the deliveries, or they deliver to the wrong place. Again, this is what happens. You have things that are happening now, like like in Houston, which the whole supply chain is altered throughout the country, and you're going to have Irma coming up, which is one of the things that we're all facing here in Florida. So all of these things are going to affect the supply chain. That is what the simulation does. I'm going to switch here into a PowerPoint, and this is how I'm just 2 slides for all of this. In terms of, this is how one group defined their demand and a coefficient of the population. They said that the population of the metropolitan area divided by the demand per day, which they got from the internet, times the distance from the town center. And then they ran some regression analysis on all of this. Here is an important slide that all of you may consider, and this is what all of you are going to be dealing with, in that you're going to select your different cities. As you can see here, Indianapolis, Louisville, and Fort Wayne with some of their cities. what they said, here's the population, the distance from downtown where their retail center is, the demand, again, estimated through some of the formulas that they had, the address and the average price per square foot. All of this is determined through cityfeet.com. So then they were able to figure out the price per square meter, the price per month, their regression coefficient, their regression average. And what they were looking at is they figured out, as you see there, via formulas, the lead time in days, the demand between the lead time, the safety stock determined at the 95% service level, and the reorder point. However, if you look down at the bottom, you will see a difference. They said actual that they had to put into the simulation to make it work were those numbers. So you see up there, the safety stock, they have 116 in Indianapolis, but in order to make it work in the simulation, they had to up that to 140. And so therefore they had to up their maximum storage capacity to 250 compared to calculated ROP, return on reorder point rather, is 220. So they had to up everything. This is one of the things that I want you to do in your presentation and in your paper, to be able to determine what the difference is between what you calculated and what the actual demand was to make the simulation work. I'll briefly go through some of the this is one that was an undergraduate product, and I'll go through this very quickly to give you an idea of their presentation. What they were dealing with is grills and stills. These are who they are. This is their product, and the product was basically whiskey, and that's why they're calling it whiskey business. The size of the product, the weight of the product, and the cost of the product. They identified their partnerships in the supply chain in terms of how they were getting certain things together. They identified the ingredients of their product, because the ingredients of the product really determine the cost of the product. They looked at, they did a SWOT analysis to be able to identify what the demand was in terms of the strengths, weaknesses, opportunities, and threats. So they identified all of this. They went in and they calculated, again, this is using some of the formulas that we talked about in class. They determining what is their advertising cost. So there was the formula that they used for advertising, and this is something that had to be plugged in when they're looking at the end, did they determine a profit. This is, again, some of their advertising, and you see that they went on TV, newspaper, and Pandora. This was their forecasting and their locations. And what they decided to do is they're selling their product to places where the National Football League or colleges are really established, because they said their main venue is going to be tailgaters. And so this was their customers identified by numbers. As you see, they looked at the different cities, and that was the percent of the cities that were football fans, the percent of the fans that tailgate, the games per year, the attending fans per year per game, the buyer index, and the demand per day. And what they were looking at here, all of these were documented by some things that they found in the internet, and they provided footnotes. Again, that continues and everything. Then they did a regression analysis of the last few years to be able to determine what the demand would be in the future. Again, this is some of their inventory plan. As you can see, the demand per day, the EOQ, some of their safety stock, the reorder point, the cycle time, reorder costs, and holding costs. All of this was basically calculated. This, again, was their product model. So they took the calculations and they put that per site that they have there. Then this was their optimization in terms of what would be the ideal safety stock and reorder point. They used the center of gravity model to determine where their distribution places would be. As you see here, some of the coordinates, the X and Y coordinates. Looking at some of the variable costs associated with their product, such as labor, electric, water, and the daily cost for each of the sites there. Looking at some of the fixed costs, such as the lease or mortgage, the property tax, and the insurance. And again, all of this was determined from the internet, primarily CityFeet, and some of the other formulas that they have. So this is the distribution of labor, the retail labor that they have, the aggregate planning in terms of putting it all together. As you see, the demand, cumulative demand relative to the population, and the inventory plus the lost sales. Again, all of this was continued with the inventory cost. Then they got into the transportation. They used 4 different types of trucks. And as you can see, the size, the lease cost, the yearly cost, the insurance, cost per gallon, cost per mile, and the maximum weight. All of these things are needed to be able to put into the simulation, which I'll demonstrate here, or Mike Hugos will demonstrate here in a minute. They also looked at the salary of the drivers. So that was imported into all of this. And then here was their supply chain layout. This is the layout that they had of their supply chain in the United States. As you see there, directly pulled from SCM Globe, your name, the price, the weight, the kilogram size, etc. This is some of the optimization, and the optimization is a result of them running the simulation. SCM Globe will provide these figures to you. And so again, this is, again, continuation with optimization. What they were doing is in their paper and in their presentation, you will see that you will have all of these trend lines, and it's up to you to be able to explain what these trend lines are all about, because there's no reason for you to go out, run out of stock or get anything over. You'll be able to see all this if you pay attention. The same thing is true with transportation. Again, the way that they had put all of the information in, their route 1 versus route 2. As you see, everything is all documented. Their routes 3 and 4 is documented. This is their buildings. And again, this is from CityFeet. As you can see, the buildings, you have a picture of the building. What I asked them to do is give me a description of the layout on how the building works, because the layout is going to determine how many square feet you're going to use for storage, which has to be put into SCM Globe. You're not going to use the whole thing for storage. You're going to have some kind of office space, some space to move around. So again, it's making it as realistic as possible. Again, this was their Nashville distribution center. This was their Minneapolis center. This is their Grand Prairie center. This was their Pittsburgh center. This was their Charlotte center, Birmingham center, Quad City center, Pensacola center, Fayetteville center. And then this was their income. Again, this was produced by SCM Globe. As you see, the product sold out, the retail market, the product sales, etc. Again, some of their expenses, the product price, the cost of the product sold, their facility storage and operating costs, the vehicle operating costs, and then their continuation of expenses, and then this was their profit and the percentage gross profit that they had. And then lastly, what this was is the the supply chain performance, and they looked at the distillery, which was the factory, their Oklahoma distribution center, their Quad City stores, etc. And they were able to list their beginning inventory on hand, the ending inventory, percent change, etc. And you can see all the stuff there. As this continues with some of their other sites, and this was all of their references. Again, documented as to where they found all of this information. This is their Excel spreadsheet that they had. As you can see, the first one is dealing with their demand, and I'll make this a little bit smaller so that you can see everything that's there. So you have the reorder, the EOQ calculations, the yearly demand, EOQ per facility, the reorder point, cycle time, and again, all of this stuff has been put into the area. This was their operating cost. As you can see, all of this looking there. This was, and again, this was proof of all of their facilities. When you look down here, they document everything. Insurance is this, and it covers everything. This was their formulas dealing with the center of gravity model, and again, some of their calculations there. This was their labor, and again, based upon this bottom site, and what that does is tell you how many employees should be employed per square footage in a different area of work and all of this per different sections of the country and their different wage. This is their product details, again, very briefly. This was their transportation of the different options there. This is a description of their different trucks and where they got all of the information from. This was their Oklahoma distribution point, their Nashville distribution center, Quad Cities, etc. So they listed each one, and as you can see, they have the reference in there, the operating cost, and to include labor, electric, water, and it comes from some of these sites, as you can see there. So with that, I think it gives you a lot of overview in terms of a lot of information, and that is kind of an overview of the a whole project. This here is was their paper, and as you can see, they went through. This was their business plan, their product, as they defined their product. Getting started, what they did, having to do all of this, their SWOT analysis, and it just describes all of these different things, their suppliers, what goes into their product, as you can see, the advertising that's in their product, and the different things that they were using there. And so their formulas all the way through are documented right there in the product. They also included some of their spreadsheets in and explained each one of them. So that's kind of the overview of the product. And again, this was another one dealing with shrimp and octopus, and this was a Nova paper. And they did kind of the same thing. They estimated the demand of octopus, and it was interesting thing is, I'm just going to show you this very briefly. They went in and said, okay, here's the section from all of this. Unfortunately, Ramiro, yes, 5 weeks. That was the other course. They had all this too. They had 5 weeks to get it done. Welcome to graduate school. And they did all of this, and that was the course that was in the spring. So they had the product definition, the facility, described each one of the facilities, and everything. And this is the product. This is what you're going to get out of SCM Globe. So this was the Nova product. Again, writing everything up. I know it seems like a lot, but you have to take one step at a time. Any questions that anybody has here before we get into the actual demonstration on using SCM Globe, either here in class or in the out there with the Nova students calling in? I think everybody's kind of overwhelmed now.
Stunned. Huh? I believe stunned is the word.
Yeah, that's a kind of a typical reaction there. Yeah, that's part of what happens there. But the previous classes were the same way. That's why I'm showing you the products that they actually did. And interesting part is that I have posted on the website, both on Blackboard and Canvas, some of the things that they produced, some of their spreadsheets. So you're welcome to use those spreadsheets. You're welcome to look at what they did. It gives you some guidance. They didn't have anything when they started doing some of this. So they produced this, and so they didn't really have any samples. And they were able to do it. What's that?
I see a question here from, and the question, I'm not sure I understand it, but is the only trans model available dedicated? Maybe if you could rephrase that. Dedicated.
Al, you said dedicated fleet. What does that mean?
Yeah.
What are you trying to ask? You could ask verbally.
Is the only transportation model?
No, you build your own transportation. Some students have ships, and they looked at bringing things from overseas and then connecting with their own trucks. Some rented trucks, some bought trucks, and they said, okay, here's the depreciation on the truck, insurance and all that, and they listed all these different things. So there's several different things. It's up to you to use your own creativity on all of this.
So this, I think a good way to say this is as close to really doing it as you're going to get before someone lets you actually do it. And what you learn here will be absolutely applicable to the real world. So that's the good news. That's the good news.
Mm-hmm.
Dennis, do you want me to?
Yes, you can take it over, Mike, and start demonstrating the actual simulation.
All right.
What I wanted to provide to you is information that you had to undertake your strategy. You had to put your pieces together, and once you put all of these pieces together, then you can go into the simulation and see if it works. But you needed to understand and lay everything out before you go into the simulation, because again, this is the simulation will help you to narrow your answers, but the formulas and everything else and how you lay everything out becomes a good plan, and that's your strategy. That's why I said, for those of you in the online course, don't wait to the end, because there's a lot of work to do.
All right. And I think what we ought to first make sure is that everybody does take a look at the Getting Started section for the simulation software. I'm going to go ahead and log in. Right now, if anyone has had problems purchasing or registering or accessing the Getting Started section, go ahead and ask that question or type in a comment in the chat box. I want to make sure that everyone is off to a good start there. There's no No scratching of heads and trying to figure out what the heck do I do to turn this thing on. Okay, I'm not seeing anything. So what we'll do is I'm gonna load a copy. I just did before we started a copy of the Cincinnati Seasonings. And Dennis, excuse me, my understanding is they're going to work through Cincinnati Seasonings first to understand the software and also understand the basic concepts of modeling and simulating a supply chain. And then from there, they're going to go and take what they learned to create their own business, like stills and grills. And that's
it's up to the groups. They're not required to do Cincinnati Seasonings, but it's up to them to just try to, especially the ones online.
okay.
There's not enough time to be able to do two of them. In past FIT classes, I have had the Cincinnati Seasonings, and they were required to do that as a midterm and then build their own for the final. So they had to do two of them.
Right.
But the FIT term is 15 weeks, whereas the NOVA term is 8 weeks.
Okay. All right. Well, I would definitely say to everyone that there's a lot of material online.
The only thing that was really, really good was the room service.
We seem to have some crossover from a different conversation going on here. I don't see where that. Anyway, everyone should then, given the expectations, you don't want to be worried about how to use the software. And the good news is the software is easy to use. It's easy for me to say that. You'll be the judge inevitably, but I'm logged on right now. I'm in the edit screen. You know you're in the edit screen because it says edit. If you click on the help screen, all of your navigation buttons will always be in the upper right corner. When you click on help, you'll open up the online guide in a separate tab, so you can always have that open. Our feeling is learn what you need to know by going through. If I go to the help section and I click on getting started. If you don't do the getting started, things will probably go downhill from there. And I want people to be happy, so please do it. If you have technical questions, we're here. You can write emails to info@scmglobe.com, and there's also submit a help ticket. We don't want to get into your questions about the course itself and what the expectations are, but if you have technical questions, we're here to help. That's what this evening is about as well. When you look at software, what you're going to be doing is essentially drawing your supply chain on a map of the world. These examples here are from a project we did with a real furniture manufacturer, European furniture manufacturer who made furniture in Indonesia and exported around the world. So what you're looking at is not a toy. This is a real application. Everything that you do, no matter how complex it may seem, is always just combinations of these four things: products, facilities, vehicles, and routes. Think of, for instance, each one of these four. There are many kinds of products, many kinds of facilities, etc. But think of them as game pieces, and your game board is a map of the world. And so you define those pieces and you place them on a map of the world. That map, in this case, is Google Maps. What you have done by defining your pieces and placing them on a map of the world is you've created a mathematically rigorous model that can then be submitted to our simulation engine. Our computers will do the busy work for you, do the endless mind-numbing calculations, and show you where your ideas will lead. You will do the creative thinking. We have deliberately not built optimizing capabilities into this, because if the computer does the thinking, well then, why do we need you? And after all is said and done, and I think Dennis actually was the person who coined this, the optimizing equations will point you in the right direction, but it is through trial and error and fine-tuning and human judgment that you find the right answers. And where he showed you earlier, the equations pointed to what should be your safety stock inventory, et cetera, et cetera. If any of you have or are presently working for distribution companies, you'll know all of your systems say, oh, your safety stock should be this, but in reality, it's often a little bit higher, just because you'll get into a heap of trouble if you run out. and things happen that sometimes those optimizing equations don't account for. So anyway, when you create that model, you can then press your simulation. What I'm showing here, I'm certainly not going to read. You can read it if you haven't already. There are then these 5 links. If you click on the video tutorials, actually everything is in these 3 videos. I know that everyone has their own style of learning, and I'm one of those people who actually likes to see pictures and text more than video, but I know a lot of people like to see video, so we've got it all. That's what these 3 will show you. If you then, and we linked them all together, so you can, wherever you are, you can always look at this menu up here. The next one is how to create it.
One of the things, Mike, is I really suggest that they go into the user's guide, which is the 3rd thing up there at the top. And
Yes.
if you go down in the user's guide, that really is going to tell you a lot of different information to use, give you suggestions how to analyze some of the data that you're going to be finding, tell you how to structure certain things, how to make certain things work. And so it's I think it's a very good tool.
We also recommend that, like peeling the layers of an onion, you don't try to eat the whole thing all at once. There's a lot here, and I don't think it's a good idea to try to learn it all before you start. I think it's a great idea to go through Getting Started, which after 4 years of feedback and a lot of fine tuning, we think we're actually getting to something that's it's going to get you up and off to a very good start in 15 to 30 minutes. You can look at the videos. If you some of the other tutorials are all we did was we pulled screenshots out of the videos and then put some text underneath it. So any way you want to learn, it's all here. Go through that and then get started. Learn the rest as you need, and there is a lot. You'll know, I don't know what percentage, 20%, 30%. There is a lot, and you'll get into it as you need to know it. For instance, this simulation, supply chain modeling and simulation techniques, tips on building supply chain models, useful stuff there. Some of these, analyzing a sim results, you can do that. Take a look. All this stuff is going to tell you more, but learn what you need to know as you go along. Otherwise, I think you'll probably feel overwhelmed. You'll start to have headaches, nausea, vomiting will follow. So try not to do that. And when you look at any model now, what we've done is we've put here are the 4 entities, the products. In this case, there's only one of them. And in your project, you'll only have one. But you really are thinking of this as a shipping case. This company makes many different kinds of spices, but we don't ship individual little 4-ounce packets. We ship cubic meter sized pallet loads of a mix of those spices, and that's what the spicy cube is, so you can see its price, etc. If I click on facilities, here are all the facilities. When I click on a facility such as Fort Wayne, it'll bounce the facility. I'll close that out. It'll bounce the facility, so as you get more and more, you'll know which one you're clicking on. And then it tells you a little bit about it, your storage capacity, your rent cost, your daily operating cost, etc. And then here's your demand per day. Here's your quantity on hand. If this was a factory, like if I go here and click on the seasonings factory, we see what our production is. There is no demand because you don't consume the product at the factory, you make it. When I click on the DC, you'll notice a couple of things. Number one, there is no demand at the DC either, because unless you consume the product at a facility, you don't record that as demand. The product will be picked up there at the DC and delivered to the stores, but the demand is out at the place where the product is either sold or consumed, not anywhere else. And what I also noticed when I clicked on the DC is that whenever there are vehicles and delivery routes that originate at a facility, we'll paint that on the map for you. We spent a lot of time working on the user interface. We're interested in your feedback on how we can make this user interface even more useful. But what I can see now, because I know that this, whereas I click on the Indy store, for instance. Okay, I know there's no vehicles there, there's no delivery routes because I can see that. So I'm not wading through a lot of data to figure that one out. All right, I click on the DC. Now I click on vehicles. Because there are vehicles associated with this particular facility, I can click on any one of them. I can see where they go. So, I can see that. Here, that's a multi-stop route there. These others are single-stop routes. When I have clicked on any one of the vehicles, here's the data. And again, so I hope what you're starting to see is, okay, there's a lot of things to think about, but we have defined those things in 4 entities, being products, facilities, vehicles, and routes. And the data that I need at the end of the day to make my model and run my simulations is only a handful of numbers about each one of those 4 things. So we're not talking about oceans of data. Now, once I've selected a vehicle, I can click on the route, and here I see a little bit about the route that vehicle is running. I can see that it is going down to Louisville. You can name these routes anything you want. I've just kind of learned from experience it's always a good idea to name them, where they come from and where they're going, just to keep it all straight in your own mind. I can see what's happening. It's running down there to Louisville. It's dropping off 20. When I look at the vehicle itself, I can see the delay between departure, which is basically how you set the frequency, is 22 hours. What that means is my truck is going to run down there to Louisville, and when it comes back, it will wait 22 hours before it runs its route again. I can see my the time and distance here, for instance, 341 meters round trip. That's round trip distance. Time has taken me about 3.8 hours. So by saying 22, it's running about every 24 hours. I might want to start to fine tune that. If you just determine I need to run my truck every 24 hours, well then what is the length of the route time? Subtract that from 24. That's your delay. There you are. Okay. I have quickly gone through the model itself by looking at the 4 entities that make up that model. I'm going to click on Simulate, and we'll say, well, gee, I wonder how well that model performs. So I think it's a good idea for everyone to play with Cincinnati seasonings, use the default values. You can change any of the values you want. You'll certainly be doing that when you start to build your own company's models. And to play that simulation, I'm now in the simulate screen. You can see that, and I click on the play button, and it will start to play the simulation. And as the days go by here, we'll get more and more data. We'll start to see trend lines. And these numbers here, total operating cost, which is your rent plus your operating cost. We have deliberately built pitfalls into Cincinnati and actually plenty of the other case studies just to engage you early on. In this case, we've run out of storage at Fort Wayne. What you're basically doing is you're using the S&OP planning process, sales and operations planning process. Some of you may be familiar with that already. You can Google it. It's a 5-step process. Is there a question online? Did I hear someone? Okay. Then what you're doing is once you've defined what your markets are, what the demand is, you're coming up with your demand plan, which basically is what am I going to sell through my stores, and then your supply plan is how will I supply product to the stores to meet demand. And what the simulation is doing is checking to see if your supply plan meets the demands of your demand plan as succinctly as possible. Instead of you doing all the math, the simulation is doing the math. What we can see is on the second day we ran out of storage up there in Fort Wayne. I can do anything I want to fix that. In this case, I may decide to I will click on Fort Wayne store. I will say, you know what, if we need more space, all right. We always say first get your model to run, then circle back and start fine-tuning it to reduce the amount of on-hand inventory across your supply chain and reduce your operating and your transportation costs. But it's an iterative thing. Do not try to get everything all figured out and then load it up and do a one-time through. You could try that. It won't work, and you'll get angry and frustrated. But if you instead just start Make your best guesses as you go through doing your research. People will agonize over things like, I see there's a question here. Does the system
Yes.
perform regression analysis and use others say, well, no, it doesn't. But that's what you do. That's what Excel does. We haven't duplicated functionality. We haven't. Some people will absolutely freeze up and they'll say, well, I don't know if my rent cost is $3.25 per cubic meter or $3.50. And you know what the answer is? Does it really matter? The answer is good enough. The world is changing a lot. If you're freaked out at the second decimal place of accuracy, you're probably going to wind up as
I saw your comments, and yes, I would recommend using Excel for if you're going to do a regression analysis. I think that you can use Excel for any of the formulas that you're going to be dealing with. And if you look for the NOVA students on Blackboard, I have put some templates on there that actually have some of the formulas embedded into Excel. So you have to understand what the formulas are, but they're there.
Yes, use those templates. We have focused on creating something that is easy for me to say because I'm involved with my own software, but elegant simplicity is what we're looking for, not wicked complexity and devilishly clever, because the problem with complexity is, although it theoretically does everything, no one knows how to use it, and it's functionally useless. So we focused on doing...
Excuse me, it's up to you. It's up to each one of the groups to go into the internet and find the data. We're not going to give the data to you. Depends upon what your supply chain is. You create the data yourself, and then you could use it into Excel however way you want to. I'm sorry, Mike.
So no, but here's what you're all starting to go. You're all starting to realize, wow, this is like the real world. It is. This is what you'll be doing when you get hired as a manager, or if any one of you are thinking of starting up a business, anything from importing flowers from Ecuador to starting up grills and sills. This is what you'll be doing. This is what you'll have to figure out if it's going to work in the real world, and everything you do here will be directly applicable. While we were talking, I just ran, we upped the storage space available there in Fort Wayne. We ran it again. We're now looking for where's another mismatch between what is our demand plan and our supply plan. And we're finding that, oh, gee, in Louisville now we've delivered so much product. Or wait a minute, in Louisville, it's the opposite. It says right here, you have run out of spicy cubes. So if I click on the Louisville store, I can see, right, my on hand is gone down. I can see a lot of things now. I've run my simulation. I can see that as I run over the dots here. So we ran the simulation for 7 days. I can look at, for instance, in those 7 days, these are my running costs for my vehicles. If I look at the products, here's where the products are at this point in the simulation. We're going to shoot for a 30-day time period, because beyond 30 days, let's all be honest, we won't have to tell anyone outside of this call, but beyond 30 days, the world is kind of a mystery. And so for the same reason that, for instance, beyond about 7 days in a weather forecast, it's kind of a mystery. So we focus on what we can do well, which is 30 days. This correlates with 30-day S&OP cycle. All the professional organizations are endorsing S&OP, 30-day S&OP cycles as the best practice. What this means is that every 30 days you're going to be steering your company. You steer through an uncertain world in 30-day windows. You make your best guesses and estimates and forecasts for 30 days, and you really focus on doing that well. In the real world, companies are doing rolling 30 days. Every 30 days, they can make major changes to everything from their production schedule to their delivery routes, etc. So that's what we're doing here. What we find right now is, okay, we ran out of that spicy cube. What I'm showing you is that there's a lot of data. If I click on console, for instance, here's all the data that was calculated. And whenever you run into a problem and the sim stops, or when you click on the stop button, you'll see this button will appear. Export the results to Excel. It's actually any spreadsheet will do. You are exporting a CVS, comma separated value file, CSV file. If I click on that, it'll open it up. and I'll just show you a little bit about what you have here. This is showing me we ran for 7 days. Well, actually, we ran for, in some cases, 7 days, in other cases, 6 days. What it's showing me is the seasonings factory, my on hand. So it's broken up into sections. We have on hand, demand, production, what comes in, and those numbers, the in numbers are cumulative, so you can subtract one from the other to get your dailies. What went out, it's also showing me the facilities cost report, cumulative again. It's showing me the vehicle cost right here as well. So what we're starting to see is there's loads of data, and what I'm saying is you're looking to balance your intuitive understanding of how the supply chain works with your analytical ability to investigate problems and come up with good solutions. I think it's a good idea to use the visuals on screen first to get your supply chain generally going in the right direction. Then you can download this data and analyze it 7 ways from Sunday and really fine tune it. But again, as Dennis has already showed you, the equations will give you an answer that points you in the right direction, but you will need to fine tune it and run it in the simulations to really get a good answer. So in this case, if I need to get more product down to Louisville, well, gee, boss, what can I do? Imagine if you are the supply chain person in charge here, and we also, if I click on the help screen there, it opens up. If I look on case studies, there is an introduction, and it's a detailed introduction because Cincinnati is the case study that most people start with. We put a lot of useful information in here. Again, I'm not going to just read it to you because you'll have time to do that on your own. But what I will point out is that we explain the challenges. If you work through the first 3 challenges, which is first, get this to run for 30 days, do whatever you feel is necessary. You'll learn a lot in that process. Then add new stores that don't currently exist. We show you how to add a store in Chicago, and then we give you a vague notion of where you should put one up in Columbus and show you how to do a little bit of research to find it. This is where you're going to be using city feet. You'll pick an actual location. In these simulations, you don't just generally have a store somewhere in Chicago or a factory somewhere in Cincinnati. Because we're leveraging the power of Google Maps, you can see if I zoom in on Google Maps and I switch over to the satellite view, look in the upper left corner there. I switch over to satellite view and I keep zooming in. Oh, look, this is a place where you really would find a factory. This isn't just in the middle of a residential neighborhood or something. This is the level of reality. Sometimes people say, well, did you program the computer to reject a factory if you put it in a residential neighborhood? And the answer is no, we didn't. But then you can also look too. So everything you do will be easily checked by you, your colleagues, your professor. But you'll notice that when we did the research, for instance, the distribution center is exactly where you would expect to find a DC. What does it say in your lectures, in your reading? What's the best practice? Put a DC on the outskirts of town near a major transportation node, whatever the heck that means. Okay, here's what that means. Obviously, here's where 2 highways are intersecting, 2 major highways. Plus, as I zoom in, oh, look, there's a big rail yard there too. And then, well, golly, Sarge, look, this really is where distribution centers are. Look at all those trucks. Exactly. That's all of this, to Dennis's point about, because when you open a new store, the next question is, how do we get product up there? Do I fly it in by helicopter? Or do I send it by rail? Do I run a big truck up there? Can I get a big truck in there? Those are all questions that by leveraging the power of Google Maps, combining it with the modeling and the simulation ability that we've put on top, you have a very powerful tool. Are there some people that have questions? Okay, all right. Well, are there some specific? And I'm guessing a good number of you have already had a chance to look through.
Mike?
Yes, go ahead.
Mike, you've got a question here.
Yes.
Question from one of the students is, how do you use 2 modes of transportation? Can you just show that?
Yes.
How do you catch it?
Let's say I have decided that in order to solve this problem in Louisville, I'm going to use a truck, and then I'll also use, how about an airplane? Let's make sure we just get that product the heck done. Was there a question? Okay. So what I'm going to do now, I can do anything I want. This is what we call a sandbox. It means you can do anything you want. I could have my vehicles. What I've done here to start with, I have what is known a classic hub and spoke distribution model, meaning that the hub is the distribution center, the spokes are the delivery routes that radiate out from the DC. I've based all of my vehicles at the DC. It's a best practice. You would normally do that. You're going to get economies of scale, et cetera, by concentrating your transportation. But in your model, there is no reason why you couldn't decide I am also going to put an airplane down there in Louisville and have that airplane fly up to maybe it's a helicopter, maybe it's a drone, whatever you want it to be. So let's do this. At my DC, if I click on there and then I take a look at the vehicles, and as I recall, it was truck number 2 runs down there to Louisville. I can see that. Truck number 1 also runs down there to Louisville. Maybe what I'm going to do is I'm going to say, instead of that truck number 1 being a little truck, what if I make it an airplane? Okay, there it is. It's an airplane. Now the carry volume here is the carry volume for a typical shipping container that you would ship via air freight. But you may decide, I'm going to have, if one of those carries 6 cubic meters, I'm going to have 10 of those. Okay, so now I've got, obviously, multiply everything by 10. Add another 0 there. The speed will, of course, remain the same. The operating cost is going to go up by 10. Carbon generated would go up as well. My delay between, I'll leave that as it is. So now what I've done, and this truck now is because I've changed it to an airplane, so I'm going to change its name. I'll call it Airplane 1. And I'm going to click Update. And what I'm going to do is, now it's still using the old truck route. I'm going to delete that route there. So I've clicked on it. I'm going to click on the Remove button. Yep, remove that, please. So that is removed. Now I'm going to go back here. I'm going to click on Airplane 1. I'm going to say, when I click on routes now, there are no routes. So I'm going to click New to make a new route. I'm going to call this my Cincy to Louisville route. And now here's where I can send this to any of the other facilities that I have available. I want to send it to Louisville, so I'm going to click Louisville, and then I'm going to click on that Add Stop to Route. And notice here, and I'm going to close out some of these boxes so we can focus on what we're doing. The only box I can't close is the route box because that's the one I'm working on right now. And notice now it drew a straight line because airplanes, unless otherwise advised, will tend to fly in a straight line or the Great Circle route. So there it shows up as a straight line. Whereas if I had picked a truck, it would have gone down the road. You saw that earlier. It was going down the road. Now the same thing, because we've had students say, well, I'm going to use a barge. I'm going to ship a whole barge load of stuff down the Ohio River. I can do that. If I wanted to, these little white globes there, if I drag and drop them, that will, say maybe there's restricted airspace, I don't know, for whatever reason, we don't want the planes. So see what I'm doing? The same thing goes for ships. If I'd picked a ship, if I was going to try to simulate sending a product down there by barge, I would pick a ship, and then what I would do is I would drag and drop to make the route line follow the Ohio River. Are you with me on that? See how that, and again,
Mike, one of the things, say with the airplane,
yeah,
to be realistic, you would have to find an airport in Cincinnati.
Yeah, I was going to kind of bring that up. Right.
How the product would come from the airport to the retail center or the distribution center or wherever it was. So.
Yes, and in this case,
Right.
I mean,
So what you would do is
you would have to
go
actually deliver to the airport in Louisville and then have a little shuttle truck or however you decide to do it. Because when we zoom in, we can see that the store is right down here on the riverfront. And then
Right,
so you
that's
have
what
to
the
find
question is,
Louisville
Mike.
International. And so, again, people say, well, how come the computer doesn't prevent that? Well, it's because you're all graduate students and you can figure that out. You can do anything you want, but it may be absurd. The model will calculate the math correctly. If you've come up with an absurd idea, that's for you and your colleagues and your professor to determine. Because to Dennis's point, I've had an airplane that is literally taking off from the factory and landing right there at the store. That is probably unrealistic. I should probably find out, where is for instance, the Cincinnati airport. If I go up here into the upper left corner and I want to do a search, let's do a search on Cincinnati International. CINCINNATI Cincinnati International Airport. Okay, there it is. I'm going to find it. Okay, right across the river in Kentucky. And as I pull back a little bit so I can see, all right, there's the air. If I want to start shipping by air, I need to have some kind of a deal where I have a little shuttle truck or whatever, probably a shuttle truck that would be running from the factory probably, or could run from the DC, whatever, to the airport. And then from there, I would need to find where is Louisville International. See if there is, I don't know if there is a Louisville International. Maybe not.
Louisville Airport?
Yeah. Let's see. Oh yeah, there is. Okay. There's Louisville, or Louisville, as people in Louisville pronounce their city. So there's Louisville International. All right, again. So Dennis's point. Now I could say instead that is a drone. I could say that's a drone, in which case, or it's a helicopter, in which case you probably could fly from point to point. But of course, you need to find out what the cost of a helicopter is, which would be more expensive than air freight, that's for sure. But if this was a disaster recovery, disaster response or something like that, we may be using helicopters. So you see where I'm going. It's up to you to be intellectually rigorous in your model, but the computer will do all the calculations. It won't prevent you from doing anything, though. We did not build a computer to slap your wrist. We built a computer to help you figure out where your ideas will go. Other questions?
So in essence, for the project, to answer your question, if you were going to use an airplane, then you would have to fly from airport to airport. That would be the airfare. So you'd have to do the costing for the aircraft, the crew, etc. for the aircraft. You would also have to get a truck along with labor and all the costs from the airport to the distribution center, and then back of all that. So you have to think about what you're doing, and that goes right back to how do you design your supply chain. And you could get as sophisticated as you want, but you have to think through all the costs. I've had students who import things. Well, when they import certain things and they have a ship, well, they go to a port and the product has to be unloaded, so that's a cost. You have storage at the port, that's a cost. You have labor at the port, etc. And then you have to have a vehicle, usually a truck, that transports the product from the port to wherever you're taking it, to the factory or the distribution center or the retail center. All of these things are extra steps, are extra entities that you have to program into the simulation. So it really causes you to think about what the simulation really, what the supply chain is really about. How many different pieces does it have to be able to get a product from point A, wherever point A is, to point B? So you're considering everything, and that's the whole purpose of this assignment, of this the project, to get you to think about it. And for the NOVA students there, I know it seems overwhelming to you to see all this and listen to all this, but again, what I'm forcing you to do is to design your supply chain strategy, but think your strategy through so that you will try to optimize all the cost in terms of trying to see what it costs to be able to take a product from point A to point B. So that's why I said try to get a simple product, estimate demand, figure out all of your areas, what kind of facilities do you need in those areas, what are all of your fixed and variable costs, etc. So you're going to cost everything through, and you're providing a rationale, and you're seeing if it works in the supply chain. So it's a realistic application of what you're doing. And then once it works, you're going to examine all of the different trend lines that you get and to see what kind of adjustments you want to make to that supply chain to be able to make it work. So look at it as like a big game, and what you're doing is just trying to get it to work. That's all. So it's again, it's a lot of different pieces, but all these pieces have to be put together. And again, for both the FIT students and the NOVA students, you will have some samples up there. You will have some templates. I will give you some sites. Now, that doesn't mean that you have to use all those sites. They're just suggestions. Mostly, like the one with the whiskey, they went into their own sites. They did all the research, and the two girls that did it, they made it kind of a fun project. As I said, it's not many undergraduate classes that your professor tells you to take a field trip to a distillery, but that's what they did, and that's where they start getting a lot of the information. And so they really kind of made a fun trip, fun of it in the whole project. They said it was a lot of work, but I think they ended up doing a good job with it. And this was an undergraduate class. And again, some of the NOVA products that I put on, they were done in 8 weeks because it was an online course. The students that they had, some were as far away as Australia, so they also had to deal with different time zones in trying to coordinate the groups and everything, and they were able to do it. Yes, I know it seems like a lot, but you will see that I think that it really becomes challenging, and it becomes satisfaction once you get it.
And here, this is something that Dennis and I have been working on for a couple of years and refining it. This is so Dennis, in your class, S&OP, people are familiar with that 5-step S&OP process.
Sales and operations planning, yes.
And so basically what you start to see is, and it's here online, very streamlined 5-step process. It's a great framework to organize your thinking. And as you work through each of the 5 steps, you generate data that then go directly into the model. So out of your demand plan comes your product specs, how big is it, what is it, and then it will tell you also the demand that will happen for that product at each of your facilities. In your supply plan, it's going to be vehicles and routes. Directly, so these things go directly into your model, and then the simulation reconciles those plans. These are also the actual 5 steps in the S&OP process, all of which I think adds a level of reality, and what you learn here is directly applicable, like tomorrow afternoon, to the real world. Are there other questions? We're pushing a little bit past the hour. I certainly have time. We'll answer all the questions that people have before we wrap it up tonight. So go ahead and type in questions into the chat box.
Any questions from the NOVA students there online, or maybe you just got overwhelmed with it and just kind of got tired and said you got to go get a drink and something. So
I have a headache. I have a headache. I need a drink.
Anybody type in the questions? Cal, yes, it is a lot to digest. That's why we decided to record this, because you can't comprehend all of it all at once, but you can go back, play it and replay it when you need it. What you can do is look at some of the samples that I put on Blackboard. As you look at the samples, also look at some of the Excel spreadsheets. When you look at the Excel spreadsheets, you will see how other students have approached the problem. There's formulas in there. They should be helpful to you. Again, I don't want you to simply replicate everything. That's basically plagiarism. But what this is dealing with is, I believe that it's a learning experience to be able to give you some samples, because I know it's confusing, especially if you're out there online trying to digest all of this, as Cal just said there.
Well, I would also say that as far as the software goes, there really is everything you'll ever want to know online. And if you run into a bug, everyone should definitely look at I'm going to go to the online guide here. Everyone, in addition to the getting started, make sure you also look at the FAQs, the frequently asked questions. There are 7, not 20 or 13. There's 7 questions. I guarantee that every one of you will run into one or more of these. And if you look here, you'll answer it quickly. Otherwise, you'll waste hours. You'll become frustrated. You'll talk badly of my software. And I want you to be happy and engaged. So there's 7 most frequently asked questions. Check them out. And then also, we are listing, when we find bugs, we list them here. So there are presently 2 bugs we are working on. Each bug has a workaround. Neither of them are fatal. Neither of them will cause the results to be erroneous. But they are in the nature of a hassle. Sometimes I won't go read it right here. All the everything you'll need to know in terms of if we find a new bug, it'll be right here, what the workaround is. So everything is online. We've had going into 5 years now of experience with students, feedback. We're interested in making this thing easy to use. It is Apple compatible. You're running on a browser here. This will run on any browser except for, you'll see, number 1 question, what browsers can I use? Any browser except for the Microsoft browser, which has a non-standard implementation of Java, so we don't support it. But we support Chrome, we support Safari, we support Firefox. So we're very frank about that. Dennis, I think early on mentioned that sometimes deliveries don't happen exactly. People will be going along and then we'll get an email saying, hey, I was expecting my truck to deliver something on day X and it didn't arrive. Is that a bug, or there is a bug? And no, actually, it's a user-friendly feature. It's an old software joke. But we explain what we mean about that. You should look into some of the stuff about how there's what are called day 0 calculations, because no supply chain ever just starts from a standing still to running. Every supply chain is in motion. It's already in motion. All supply chains are about motion, not about starting from a standing start. So anyway, all of that is here. Everything is online. I think you're going to have, and actually there was an interesting observation made a while back by one of the professors who said it reminds him of learning, because obviously he had taken some dancing lessons with his wife, and he said, wow, it was really awkward at first. I really didn't like it. It was and then all of a sudden something clicked and it was great and I was a hero. And the same thing will happen here. When you get the hang of this software, you are going to be the master and commander of supply chains that would otherwise be beyond your ability to really picture and manage. Once you get that, you're going to really be on a roll. So it'll
also, a few of my students have actually taken some of the software, taking it back to their corporations, and they emailed me and said that their corporations are actually using some of it. So again, it is very realistic. It is demanding. The product or the project that you are going to be required to do for the course is demanding, and it has a lot of different pieces. That's why I keep telling everybody to don't wait to the last minute, because you're not going to be able to get it done in the last minute. And in the NOVA course, I forget who it was, but somebody said that they had worked with a importing furniture, or they are currently working with importing furniture. And a real example that's in there is the Java Furniture Company, which you could go in and play with.
This is a real company that we worked with actually in the fall of 2014. And what this case study is we've changed the names and some of the numbers to protect confidentiality. But otherwise, this is a pretty accurate description of what actually happened in the case. So again, what you see is what you learn here is directly applicable to the real world. This isn't a game about a make-believe fruit juice company somewhere that is making, widgets, whatever the heck a widget is, and shipping it off to Boston, wherever the heck Boston is. This is real. So have at it.
Feel free to play with anything, look at anything. There are several of the samples that I did. For example, in last May, I presented a paper and a demonstration of this simulation of evacuating refugees from Aleppo, Syria.
Here it is.
Using all of the 10 classes of military supply, and costed all of that out. And so it was.
There's a little. This video right here will give you an 8-minute overview. And as Dennis is saying, actually Dennis and I and another colleague worked on this. Dennis presented that in May in Rotterdam at a big military simulation conference. So that is all here online as well. And plus, you can load the model from the library. You can see what we did was we created a streamlined version of SNOP, and we're calling it Mission and Ops Planning. You can see a lot of stuff here. So,
okay. Any questions from the NOVA there? Any NOVA students? Anybody still left out there, or you just decided?
No, we still got people online. All right. Well, people are reaching for a glass of wine or even whiskey. All right. Everyone.
Mike, the question is: yes. Is there a limit in the number of save states that you've got here?
We haven't found it. I'm going to go back because I have a lot of save states, and I'll just click on my account, and I'll go to my account, and you can see your management screen is the top half is your active models, and then as you go down, the bottom half are your save states. It's always a good idea before you we don't have an undo button, and plenty of people have said, gee whiz, I just blew 3 hours of work by making a change, and now I want to change it back. And the answer is restore from a save state. Oh, I didn't make a save state. Do you have an undo button? We don't. So as you're going along, before you make a big change, there's a couple ways you can do it. You can do it from your account screen by just clicking on save, and it'll ask you to enter a name and then click save. Or when you are editing, if you're in your edit screen, you can do the same thing. Let this paint on the screen for a second here. But if you click on your options button, it will then save a copy as well. You can save multiple copies under the same name because they will be time stamped, and so you can see what is what. So if right there I click on options, if I go down and click save, it will create a save state that way. So I hope that answered the question.
Other questions from all of you in class here? I don't know, James, I don't know if you're on from the FIT class. James on?
Let's see.
Okay. Yeah, okay. I know because he was on travel and he was going to try to, but
Right.
ask if he had any questions. But anyway, hopefully from the NOVA group, you have at least one student from each of the groups that I have created for the class. That student probably is overwhelmed, but it's basically up to you to be able to try to communicate to the rest of your group what the project is all about. And yes, I know it's quite involved, but long trips are started with the first step. And so if you actually go in and follow the sequence that I have tried to provide you, look at the examples that I have there on Blackboard for NOVA and Canvas for FIT. The different information there will help you. The Excel spreadsheets have a lot of the formulas that are in there. All you have to do is plug numbers in. However, you have to understand what those formulas really are telling you. And then in your paper, you have to be able to explain why you use that formula. What is it that you're really trying to explain? And in this class, this is the introductory supply chain at the undergraduate level. So you will be introduced to a lot of these formulas. I know I see your faces here and you're just as overwhelmed as the students online, I imagine. But again, long journeys are started with the first step. And that's what all my other students said. We have to do this term. Yes, and they didn't believe it, but they actually produced quite a bit. And so it was, again, the course challenges them. Again, I'm not going to be critical of you and what you do, what you don't do. But I want you to try your best to be able to create a legitimate supply chain, and I'm going to be asking you to provide a logic as to why you did certain things, because the way that you think may be different from the way someone else thinks. That's not to say it's right or wrong, but we will just try to do that. But what I'm asking you to do is all the things that are done in a realistic supply chain, and that's the whole purpose of all these courses, is to teach you supply chain management. And supply chain management means that you're managing all of the entities of the supply chain, which includes those 4 elements that Mike talked about, and all of them are in this simulation here.
All right.
Okay, any final questions before we leave? Oh, Mike, why don't you just mention where they are able to find this recording of this here?
Well, I will send you the link tomorrow. What we'll do is we'll process it tonight and we'll post it on the YouTube channel for SCM Globe, and I'll send you the link, Dennis, tomorrow morning.
Okay, and for the NOVA students, what I'll do is I'll put the link on the announcements, and for the FIT students, I will also put the link on the announcements so that you can go back into here, look at or listen to the video, because there was a lot of information in the last hour and a half that we had. You can't comprehend it all at once. It's very overwhelming. But as you start putting together the different things, you can refer to certain pieces and say, oh, that's what he means, and oh, this is what I can do. So you can refer to it from that perspective. So that's how you use it in combination with the samples that are there in your Canvas or in your Blackboard for NOVA. Again, use them as you see fit, but please don't copy them 100%, because that's plagiarism. You have to create your own. Again, I'm only putting them there as templates, as samples from what other students have done in past courses. Okay, anything else? Well, have a good week, and hopefully everybody stays safe from the hurricane that's going to be coming in, because I know a lot of the NOVA students are in different cities in Florida, as myself, we're here in Orlando. So hopefully everything is going to turn out pretty good. Have a good week and a safe week. Thank you, everyone.
Good night, all.
Good night. Any questions from you guys over here? What are your thoughts? What do you think there?
It almost seems like you could do some of it. I know this may sound crazy, but in a sense, backwards. So like you could create everything and see what works, and then build everything around that. Like so, like what spaces you need based off of what you did in the template before like throw a test run.
You could do that, and as a matter of fact, one of the premises in the other course in the they use this textbook in the other course. What he advocates is, again, it's supply chain transformation. What he is saying is that people should build the supply chain backwards. That most of the time people say you start with your suppliers, like I was talking about. You determine who your suppliers, where you're going to get that, and then it goes all the way up to your factory and then your distributors and wholesalers and then to the customer. But what he is saying is you look at your customers, see what they want, go back to the wholesalers or the distributors, find out where they are willing to get them. Are they willing to go to Costco or whatever? Then go back to your factory or whatever it is, and then determine your suppliers. So you're working backwards. However, the key part about trying to determine that is you have to create some kind of supply chain first to be able to do that. And what I'm asking you to do here is to be able to, if you go into cityfeet.com, which is a realty type of site, you have to find certain buildings that are available to rent or to buy. And it's up to you to find those buildings. Now, you don't know if you want a building that's this big or a building that's this big. Okay, what is going to tell you how to do that is how much inventory you're going to keep. And how much inventory you need is going to be based upon what your forecasted demand is. And so all of these, like it's a building block approach. And so what we're going to be doing next week is we'll start getting into how do you forecast how much of a demand you're going to need. And that's why I'm saying it's important for you to be able to figure out what your product is in your supply chain and start thinking what kind of supply chain do you really want, because there's differences. For example, is your supply chain going to be something similar to Sam's or Costco, where you go into Sam's or Costco and they sell everything in bulk? Well, you can get this water at, say, per bottle of water would be, say, 50 cents when you go in because you're buying a large case. Those people, they get the cases delivered in huge tractor trailer trucks because they buy in bulk, so they're able to sell it cheaper because they're selling it in bulk, okay? But what kind of people do you really want the supply chain, and again, this is your strategy, what kind of people are you serving? Generally, the people that go to Sam's and to Costco are the ones who have families, who have houses, and they're buying in bulk because, number one, they have to feed a lot of people. A lot of people are going to be drinking water. Number two, they have room to store it, okay, because they could put it in the garage, they could put it wherever. But if, on the other side, say if you're single, living in an apartment, and are always on the go, you don't want to buy a whole case of water, and so you're willing to pay 3 times more for this bottle. You'll pay $1.50 for this bottle because, number one, you just want one bottle. You don't want a whole case of them. Number two, you want it cold. You don't want it warm, type of thing. Number three, you want it now. You don't have to stand in line. So you're going to go to a 7-Eleven and you're going to get this. you are willing to pay more for the convenience of taking it as you are driving. Okay, that's the strategy that you guys have to really try to determine. Is do you want is your supply chain going to serve families in bulk, or is your supply chain going to be like 7-Eleven serving individual ones? Because the cost is going to be different, but the supply chain strategy is also going to be different. For example, at Sam's and Costco, they get a huge truck delivered maybe once a week because that's what they need, all right? At 7-Eleven, if you look at 7-Eleven, they maybe have 10 bottles lined up in the cooler. And if somebody comes in real thirsty and they buy all 10 bottles, they're out. So that's why, according to that strategy, they have deliveries like 3 times a day and what's called milk deliveries, because they come in from a distribution center. They will go to all the 7-Eleven or Circle K's or whatever, and they have accounts. And so they drop just a couple off at each one. They're not a whole big tractor trailer. So that's what you have to determine in your supply chain. How is it to do that? So again, what I want you to do is think about a product that you would be comfortable with building a supply chain for. And then once that product is there for this course, we're going to go into some forecasting models. And I'm going to start with the simple ones and go into the more complex ones, so that you can really be able to determine just what that demand is going to be, and you can start forecasting things like this. So once you get that demand and everything in terms of forecasting all these different things, then you will start saying, oh, okay, I'm going to have a demand of, I need 150 a week. And so you say, okay, if I need 150 a week and things are this big, then I need a facility that is going to be able to hold 150 of things this week. And I determined that the cities are, say, Tampa, Pensacola, Jacksonville, Miami. So go into these cities, you would then go into city feet and say, okay, what kind of retail place would I find there? Where would my distribution center be? Where would my factory be? So you're going in and you're actually looking real time where places are for sale. And you pull up these figures. When you pull up these figures, it will say, we will, lease this for this much per month. It is this big, has this many square feet. It's located at this address. And so you go in using SCM Globe, you zoom down in all of this. Once you zoom down, you can see exactly where this is on a map view or on a satellite view. And you can see, well, could this be a distribution center? Can trucks get in there? If it is a retail center, and who can get in there? Is it populated? Am I going to have a big turnover? So all these things are things that you're going to have to think about, and that's one of the things we're going to be talking about next week. But it will be a lot easier if you think of what your product is, because once you think of what your product is, you will now start saying, okay, yeah, this is the formula that I'm going to use. This is the way I'm going to forecast it and be able to see what that product is. And there are some sites that are in the web that will give you projections, just like the one shrimp and octopus. You think, well, geez, this is kind of a weird thing. Who would think about this? Well, it was a business that one of the girls in the class worked at. And so she said, okay, how am I going to determine what is the capacity, what is the demand for shrimp and octopus? She was able to go into the internet, and in her paper, I think I've got that documented right here. Let me see if I can find it here. A report issued by the Environmental Protection Agency in 2002, we find that a person in the U.S. consumes an estimated of 2.2 grams or 0.02 kilograms of shrimp per day and that much octopus per day. So she was able to find that based on statistics. Now, That was in 2002. So they says, with these demands, we calculated how much octopus and shrimp a person consumes in a year. Furthermore, from the Office of Economic and Demographic Research in the state of Florida, we found the 2015 population in the metropolitan areas where our retail stores are located. The information said, okay, here's the annual demand per cap, demand per shrimp, times the population of Miami, which is one of the areas she's dealing with, equals this is the annual demand. Dividing by 365, we're able to calculate the demand per day. So that's the daily demand of shrimp in Miami per day. And so they said that one of their assumptions is that their store would only provide 20% of the market share. So they says, okay, 20% times the daily demand, that would be the daily demand for their store. You see that? So that's the logic that they use to be able to establish the demand for the store. Does that make sense to you guys there? See, so you have to be able to do some research. The information is there. And the key part is everybody's overwhelmed. They say, where do I start? There's so much stuff. Where do I start? First of all, you have to start with a product. This is the octopus one. This is the shrimp one. All you do is go into the internet. You can find information about that. And you just use some logic, and you already have your daily demand. So now from there, you basically said, okay, this is the daily demand. This is how much the weight of a case of shrimp is. So that means the daily demand for a case of shrimp in Miami store is that. So now there's the product definition. See, they're defining how much it weighs. Now, why do you think they are defining how much it weighs and all that? How much it costs, but what else? What else is going to be important?
When you transport it.
Exactly, because the weight determines how much it's going to cost to transport it. And then they went into the facility, okay, and they says, okay, when we have a facility, this is a sample for all the stores. And they said the stores would be laid out like this. And that was a simple way because they're saying, okay, we want all the stores to be the same, which is, good point. And by laying it out this way, it's going to determine the amount of area that you actually is going to have available for storage. Because when you look at a store, part of the store is going to be display. Part of the store is for the cashiers and all that. Part of the store is for the office. There's only part of the store is going to be actual storage of the product. But when you go into the simulation, that area that is going to be the storage of the product is what you're going to have to put in. Does that make sense? And so based upon this, they said, okay, this is our Gainesville store. And they are able to go into the internet, pull all this stuff out of the Gainesville store. And this is your printout right from City Feet. And as you see, it will tell you that's the space that's available. That's your rental rate. Minimum divisible is 750 square feet. Maximum contiguous is 19,151 square feet. You can lease it. It's a retail. There's the building size. There's the listing, and then they have, let's see, that's the address. So you put that address into SCM Globe, and you zoom down, and that's what you get. And it will tell you exactly where it is, and you make the determination, is that a good place? Think about it from a marketing perspective. Are you going to have a lot of people coming there if it's a retail store? If it's a distribution center, what's the ease of access of getting trucks and transportation and all that? So that's what you're going to do for each one of the areas there. And you see how they listed each one here. And so that's their data that they're starting to come up with. And you could really find that, and just go into the internet, sign one of the group members to find that, and it'll just take you 30 minutes to an hour to find a good property, and you come up with all of this.